Alright, and welcome to the ultimate guide to visual transformations. Now, in number one, it says describe the type of transformation that occurred in the graph below. Alright, so a little bit of a typo in the wording, but yeah, describe the type of transformation that occurred in the graph below. Well, notice it really seems like these two triangles are pointing at this line. So the first question we want to ask ourselves is, what is this line? Well, it is our x-axis. Okay? So whenever we're across this line, what we want to determine, was this a rotation or was this a reflection? Now, if this triangle had actually been pointing in the same direction, like if this triangle right here is pointing up, if it was pointing up right here, they look the exact same, that would be a translation. But they don't look the exact same, so clearly something happened. Okay, so how do you determine if it's a reflection or rotation? Well, for a reflection, these points would be equally distant or equidistant from that line. So notice C to C, those are the same distance from that line. From E to E prime, those are the same distance from that line. And from F to F prime, those points are the same distance from that line. And so we say that this is actually a reflection. It is a reflection across the x-axis. All right, so this one's pretty easy. Okay, so if the points are the same distance, well, you know it's a reflection across a certain axis. All right, now number two is a little bit different. Notice, yeah, the triangles are pointing in different directions, but they're not right beside each other. What do I mean by that? So this triangle right here, CEF, they're not in quadrants next to each other. Okay, so remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and of course this is quadrant 4. Well, if they were right next to each other, hey, this would be easy. This would clearly be a reflection. All right, but it's not. Okay, so we'll scribble that out. Yeah, and what if it was right here? Well, obviously we'd have a reflection there. Okay, but it's not, so we can scribble that out. So what is it that flips our triangle completely upside down, but goes across two quadrants? Well, this should be pretty easy. This is what we call a 180-degree rotation. So this is probably the easiest of all. If you've gone two quadrants away, it is 100% guaranteed to be a 180-degree rotation. Let's go ahead and look at one more, which is going to be a little bit tricky. Okay, example 3 is probably the one that concerns me the most. So notice, look, these two triangles are right beside each other, so they could possibly, the quadrants are right beside each other. Here, this one's in quadrant 4, and this one here is in quadrant 3. But even though they're in quadrants right next to each other, well, notice that they're not both pointed to the same line, or aka they're not equidistant. Like if I draw a dotted line from C to that line, and then from that line to C prime, notice that this distance and that distance, they are completely different. So this one cannot be a reflection, all right? We know it cannot be a reflection. All right. And let me get rid of at least, oh, I see. Oh, well. Okay, so the question then becomes, well, what happened? And what I would say to this is now you want to ask yourself, did the shape turn? Okay, what do I mean by that? Well, let's see here. We started with this shape, and then we go to this shape, and you can kind of see that it's like the shape, it rotated in that direction. So C was pointing up, now C is pointing to the right. Okay, so the triangle is pointing up, now it's pointing to the right. So no, it is going to be a rotation. And then you want to determine what type of rotation. Well, if it rotated to its side, going clockwise, so we know it's going to be a clockwise rotation. And remember, clockwise is whenever we go to the right, okay? And whenever we go clockwise and we go to the right one quadrant, right? When we go to the right by one quadrant, that's going to be a 90-degree clockwise rotation. However, a 90-degree clockwise rotation could possibly be, we could have really gone 1, 2, 3. We could have rotated 3 quadrants to the left, or 3 quadrants counterclockwise, rotation, yeah, okay? And if you go 3, that's actually 270. So one thing to understand is that a 90-degree clockwise rotation is the same as a 270-degree counterclockwise rotation, okay? So like I said, this is the one that concerns me the most. So just test, are the points different distances away from the axis that they could be reflected over? And if the points are different distance, you know that you have a rotation. Then you just ask, draw these arrows. Okay, this one's pointing up, this one's pointing to the right. So we know that it's rotating to the right, or AKA clockwise. You just gotta follow that logic. All right, I hope this helps, and I'll see y'all in our next video.